Hi Panthers. Today we're going to talk about the quadratic formula again. And the quadratic formula is going to help you find your x-intercepts, also known as your zeros, also known as your roots. And so one thing that's nice about the quadratic formula is that part of it, the b squared minus 4ac, this will help you tell you how many your roots that you have. This is called the discriminant. The discriminant, if we go in and use b squared minus 4ac, this will tell us whether we have one solution, zero solution, or if you have two solutions. So if I use b squared minus 4ac, and if that equals to 0, then that means I have one solution. And that's just kind of nice going in so you can tell when you get done or beforehand what to expect. And that means that your graph might look something like that. And basically that means that you have x equals 2, and that means that your values are going to be the same. So x equals 2, and we're not repeating that. b squared minus 4ac, if that is less than 0, then that means that we have no real solutions. And then our graph might look something like this, where it is not crossing the x-axis here, and so we do not have any solutions. b squared minus 4ac is greater than 0, and that would mean that we have two solutions. And a possibility for your graphs might look something like this. I have one and I have two solutions. So these are just a few of what your graphs could look like. They could be all over the place, but this is one solution. That's if b squared minus 4ac equals 0. If b squared minus 4ac is less than 0, that means you have no real solutions. And if b squared minus 4ac is greater than 0, that means you have two solutions. And this is called the discriminant. The discriminant will tell you how many roots. How many roots. All right, so now I'm going to flip over and we'll start looking at the quadratic formula, day 2. So if I have 3n squared minus 2n equals 6, we need to get everything in standard form, and we want to go ahead and get it on one side. So I'll subtract 6, so that'll have 3n squared minus 2n minus 6 is equal to 0. I'll find my a value, which is 3, my b, which is a negative 2, and my c is a negative 6. And so we're going to just go in and use b squared minus 4ac. And we want to see, just so that we can see how many roots we're going to have. So I'll plug in a negative 2 squared minus 4 times 3 times my c value, which is a negative 2. And so I'll have 4, a negative is a positive, and then my c value is a 6, so let me go ahead back and change that. And so I'm going to have 12 times 6, which is going to be 72. So my discriminant is going to be 76. Since this value right here is greater than 0, I know that when I get done, I should have two solutions or two roots, because my discriminant is greater than 0. So let's see if that works out for us. So we're going to go ahead and we're going to write our formula. So x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So I'm curious to know how many of you actually have the quadratic formula memorized after yesterday. Hopefully everybody does. So then we write x equals, because that's what we're finding, we write x equals, we write the negative, and then we'll start plugging in, and then we'll have a negative 2 plus or minus, put our square root, and we want to make sure we have a nice big square root to cover everything. I like to put my b in parentheses, negative 2 squared, and that's going to be a minus, and then 4, and then you just kind of plug in all your numbers. And we already know what's going to be underneath here because we just found it. Then a big fraction bar, 2 times 3. So then x is equal to, and we'll have 2 plus or minus the square root of 76 all over 2 times 3, which is 6. So one thing we want to find is to the nearest tenth. So we are going to go in, and we have to go in and put this in reduced radical first. And so we have to go see, can we reduce this down? And so I'm looking for the biggest perfect square that will go into 76. And so we start thinking, 2 times what will give me 76? If you do not remember, you can go in. Oh, somebody changed the language, so it looks like this one that I grabbed is in Russian. Oh, well. And so you're going to go to your graphs, and then you're going to put 76 divided by x. And then you'll start looking for your perfect squares after you go to your table. And you'll start looking to see. And so it looks like 4 and 19 is going to be, so it looks like 4 and 19 is going to be your perfect squares. So we'll go ahead and take that out. So this is going to be x is equal to 2 plus or minus, and then this would be, you can write it as 4 times 19. When you take that, that's going to be 2 square roots of 19 all over 6. And then you want to see if you can go ahead and simplify that. And so this means that you have to be able to take out a number from every single number. You can't just take a 2 out of this first part. You have to be able to take a 2 out of each part of your expression. So when I divide, I can take a 2 out of this, I can take a 2 out of this part of the radical, and I can take a 2 out of the 6. So I'm left with a 1, and then 6 divided by 2 is going to give me 3. So this is going to be 1 plus or minus 1 square root of 19 all over 3, which is equal to x. So then I will write that as 1 plus the square root of 19 all over 3. And it's going to be x is equal to 1 minus the square root of 19 all over 3. So those are my roots right there. So this is in reduced radical. I am interested in finding to the nearest tenth. And so we'll go to our calculator. I need to really get a calculator that is in English. And so then we're going to just hit Control Divide. And so you can go ahead and put 1 plus the square root of 19. Divide that by 3. If you are interested in getting a decimal, you'll just put a decimal. And then this root is going to be 1.786. We want it to the nearest tenth. And so that'll be 1.7, that'll be 1.8. And then we'll go ahead and do the same thing over here, Control Divide. And then we'll put 1 minus, Control Divide, square root of 19. 3, if we want a decimal, we'll put a decimal here. And that's going to be a negative 1.1. All right, looking at our second, we want to get all our terms on one side. So we're going to move the x over, and we're going to move the 8 over. So we'll have x squared minus x plus 8 is equal to 0. So that means a is 1, b is negative 1, and c is equal to 8. And then we're going to go in and we're going to look at the discriminant. And so we'll have b squared minus 4ac is equal to 0. And so we'll have negative 1 squared minus 4 times 1 times 8. And so this is going to be 1 minus 32, so that's going to equal negative 31. And so since this number is less than 0, so we have b squared minus 4ac, and so all of that is less than 0, that means that we're going to have no real solutions when we get done, is what that means, okay? So let's go in and see if we are correct, because we have to show our work. So we have x is equal to negative b plus or minus b squared minus 4ac all over 2a. We go ahead and plug in, and we have x is equal to negative 1 plus or minus, get a big square root, negative 1 squared minus 4 times 1 times 8 all over 2 times 1. So we have x is equal to 1 plus or minus the square root of 1 minus 32. Yep, I'll put that in parentheses, it doesn't matter, all over 2. So x is equal to 1 plus or minus the square root of negative 31 all over 2. So as soon as you get down to this part right here, and you see that you have a negative underneath that square root, that means you're done, because we cannot take the square root of a negative number. That's where we're going to start getting into our imaginary numbers, and we do not do that in algebra. So this is going to be no real solutions because of this negative right there. That's no real solutions. So this is our stopping point. All right, looking at x squared plus 6x plus 10 equals 0. So we're going to go ahead, everything is on, all our terms are on one side. We're going to find our a value, we're going to find our b value and our c value. So a is equal to 1, b is 6, and c is 10. We're going to go find our discriminant, so we'll find b squared minus 4ac. And so that's going to be 6 squared minus 4 times 1 times 10. So that's 36 minus 40. And so we know that b squared minus 4ac is less than 0, because that was a negative 4, so that was less than 0. And that means we're going to have no real solutions again. So let's go see if that works out for us. So we write our formula. All over 2a. So let's go ahead and have you plug in and see if it works out. So you should have gotten to the point where you have a negative 4 underneath here. And once you get to a negative 4, we're going to have no real solutions. Okay. So I want you to go in and you go try 4x squared plus 9 equals 12x. I want you to go find what your the discriminant is, and then work that out and find your solutions, and we'll compare answers. All right, so your discriminant is b squared minus 4ac is equal to 0. When you plug that in, you have a is equal to 4, b equals negative 12, and c is equal to 9. And so you should find that your discriminant, you're going to have two solutions, or you're going to have one solution on that one. So you have one solution. And so that's because b squared minus 4ac is equal to 0. So you go plug in your a, your b, and your c, and then you have x equals negative b plus or minus b squared minus 4ac. And then you're going to have x is equal to 12 plus or minus the square root of 0 over 8. Because you end up with 144 minus 144, which we already said was 0. And then x is equal to 3 halves. And so since this is equal to 3 halves, we do not write that as a duplicate, because if you can see, we're going to have 12 plus the square root of 0 over 8. And if we did 12 minus the square root of 0 over 8, we would still have the same answer. So we do not write this down twice as 3 halves. We only write that as one time. So my answer is 3 halves.